Hey, good afternoon. So, how many of you have ever heard of OpenBTS? Maybe half, I would say. Okay, OpenBTS was, Range Networks created OpenBTS a number of years ago, a few years ago, and Range is the commercialization of that technology. And OpenBTS was conceived of by a couple of guys that were DSP experts, specifically GSM network DSP experts, and they thought, what the heck, they do that for a living, so let's go ahead and write a base station in the living room. And the point being of that story is that they thought that mobile networks are too complicated and that software taking over the world, why not just write one in software and displace a lot of the specialized, very expensive hardware and proprietary software that was out there before. And so the moral of this story is that if you've ever looked at how mobile networks are built and how much money they spend a phenomenal amount of money, and about 70% of it is in the network infrastructure itself, the radios, the base stations, because of course there's millions of these base stations that are put out there. The architecture of mobile networks would really make you cry if you have ever come from the internet or looked at how IP works. Mobile networks, 2G, 3G, 4G, they're completely separate from one another. And though as we've quickly evolved through multiple generations of technology, you have multiple redundant networks operating out there. And of course all the cost and the complexity and the management nightmare that comes along with all of that. And so that is what accounts for the fact that the MNOs, the mobile network operators, can be spending $52 billion a year on access technologies, just access technologies, not even the server side or application side products, and still be crying that they're not making a lot of money. And so when you look at, you contrast that with the layered ISO model that the internet was built on, that IP was built on, you can see several significant differences. The first one is how the standards process applies. In the internet process, we have the IETF, the Internet Engineering Task Force, which is a non-vendor driven, people like you are allowed to attend, in fact encouraged to attend. You look at the 3GPP, the mobile network standardization process. Long hair and sandals not invited. You need to pay to attend the standards process. And typically, it is absolutely owned and dominated by the large vendors. And so that accounts for the tremendous inefficiency and the lack of evolution that we've seen in mobile network architectures. So, as was kindly pointed out, I did come from Cisco. And when wired internet came around, wired internet displaced a lot of pre-existing networks from small companies such as IBM or Digital Equipment Corporation, DEC. And of course, those networks were just subsumed into the internet, into TCP/IP networks. And at Range, the belief system is pretty easy. Why not bring some of the best aspects of what we've learned from the IP world, what you might call the wired internet world, to mobile networks, and implement in software everything that can be done in software. Obviously, there's a radio here, and I'll talk about that in a minute, but everything else can be done in software. And then open it up as much as possible so that you could innovate at the different layers, not just one company, but everybody, which is how the internet evolved so quickly and became so inexpensive on a cost per megabyte basis. The cost per megabyte on the internet just absolutely plunged over a 15-year period, and it was because you had hundreds of companies innovating down at the physical layer, moving up from 10 megabit Ethernet to gigabit fiber and so forth. At the same time, you have people innovating at the coding scheme level, at the Mac layer, so that you could have more efficient coding schemes. All of that easily coexisted in the internet model, and it didn't break the stack. And we all take this as a given, but that is not the case in mobile networks. So What Range did again then was to not only implement a base station in software, but to write sort of the necessary elements of a mobile network, to the point where you can actually have a mobile network in a box now. And there's an example in the back of the room there. And so what it is software running on a server. You can virtualize it. It's 2G. We have 3G now. We're writing LTE. And when you couple that with inexpensive software-defined radios, you have a solution that is now frequency agile, because that's what software-defined radios do. A software-defined radio, if you've never dated one before, is a tunable A to D converter. So the software is just sampling furiously the radio to recreate the waveform. The baseband processing, the DSP, is being done in software, so that in software we're doing the necessary modulation, demodulation of the signal. You can then recreate the bit pattern. And so now we have a software-based base station, but we also have all the additional bits and pieces, because in real mobile networks we have things like SIM cards, we have authentication, we have some things that are absolutely necessary. So that exists in OpenBTS, and it means that you can build mobile networks very inexpensively now. So to sort of reiterate that, it's no software, or it's all software, no hardware, and it's high performance DSP. High performance means a 2G a voice signal is really quite small. It's 5 kilohertz wide. You get into 3G, you get into LTE, you're talking about 20 megahertz wide signals, and being able to digest that at full rate and take apart the modulation scheme in software is really the trick. Doing it purely in software is critical, because it means that OpenBTS can run on ARM Beagle boards. Some of you probably have seen Beagle boards before, all the way up to multi-core Xeons. So capacity in this world is strictly a function of CPU cores. Good multi-threaded code, add cores equals capacity. And so as we move into LTE and other wideband concepts, then that becomes really important. Why are we here? Why are we working with 2600? Because Range is really, the belief here is that the cost of mobile networking, mobile access, shouldn't be anywhere close to what it is today. And we really want to, the company was founded to extend networking, bring it to parts of the world, developing countries, where the ARPU, the average revenue per user, is maybe a couple dollars a month, as opposed to the US market, where the AT&T's ARPU is about $65 per user per month. Now, of course, in Vietnam, they're not consuming a lot of data yet, but you can see the dramatic difference in the ARPU, and you can just imagine that the way AT&T builds a network here, based on $65 a month user revenue, is not going to play very big in Vietnam and other markets like that. So this technology allows the extension of networking to places where it was just not possible before. And even in the US, we have lots of rural, remote areas that are not covered. And the reason they're not covered is not that somebody hates them, they're just not economic. The density of subscribers is too low to justify that big expensive kit to be put into Wyoming or something like that. And so again, this is where a software-based approach works very well for rural, remote, developing markets. But anything that starts at the bottom, of course, moves up the stack as the code gets better and as CPUs improve and things like that. So I think that one of the most exciting parts about what Range is doing is the fact that it's a small startup company. It's nice to send software to Africa, but at the same time, it's not just about low-cost mobile networking. It's about innovation. And I think that what I always found, and I think what you find exciting about the internet, is that everybody can innovate at every layer, wherever your passion is, wherever your skill is. You might be, a PHY person. You might be an application person. You might be an IP level person. And that was the beauty of the internet stack. So we're trying to open up a stack that was not open by nature, and to do that with APIs to expose information, as well as to allow other people to drop in different layers. And so if you're not familiar with OpenBTS, it's very popular in universities, university engineering programs. When most of you studied engineering, if you did, I'm sure that your school did not have a mobile engineering program. Why? Because mobile engineering technology was never available at low cost in an open way. Somebody might give you an Ericsson base station. What are you going to do with it? It's a chunk of iron sitting on the floor. It was never designed for you to get access to it. So this is open technology, and it encourages that type of innovation, which is pretty cool, and I'll talk about some of that in a minute. Being software, you virtualize it. And since we work inherently with software-defined radios, which is as I mentioned, basically a generic box that is a tunable A to D converter that can tune all the way from 300 megahertz all the way up to 4 or 5 gigahertz. Now you have something that in software is capable of not only supporting the usual mobile access protocols, but also some of the new and interesting Internet of Things protocols. And if you follow IoT at all, you know that every day there's a new IoT protocol, a new idea on low power, wide area access, things like that. And then we're into experimentation, and it's cool that we can do that experimentation at very low cost. Spectrum. You know, you all know how important spectrum is for wireless communications, and you all know that we have various forms of unregulated spectrum, like the ISM bands that Wi-Fi runs in and things like that, Bluetooth, whatnot. But then we have what's called lightly regulated, like land mobile radios, things like that. And then there's the heavily regulated stuff that AT&T buys and squats on, so that you can't get access to it. And the nice thing about LTE is that as LTE has become a universal demand at the consumer level, governments are starting to listen more to consumers and less only to the large operators, and they're bringing more spectrum to the marketplace. So sometime in the next 6 months, the FCC is going to rule on something called Band 42. Has anybody here heard of Band 42? Band 42 is 3.4 to 3.6 gigahertz. It's 200 megahertz of bandwidth. That's a lot of bandwidth. And the model that it would be auctioned by has been proposed by Google, and in my humble opinion, the auction model that has been proposed is sort of the orthogonal opposite of the usual auction model, where AT&T puts money on the table and then essentially takes that spectrum off the table so that nobody else can use it. And under the Band 42 auction model, that spectrum will be available for everybody to use, and even if somebody bought it, they could only buy it at the census block level, something similar to a zip code, a small, very small regional area where they would apply it. And even if they bought it for that small regional area, if they were not using it, it would be available for all of you to use. So this is very important, because this Band 42 support is already built in to some of the chipsets that are being installed in mobile devices now. And so that means that various forms of unregulated or lightly regulated spectrum will be coming to the marketplace. In that Band 42 model, devices would have to register with a database to say that they want to use that piece of spectrum in this particular census block, this wonderful location on Broadway in San Francisco, for example. And that's a way to promote or allow spectrum sharing, so that, again, if we all got online here, we would consume the spectrum for this area, but other people 4 blocks away could use the spectrum differently. So spectrum is starting to fragment, and various forms of sharing models are starting to come to the marketplace. So some of the people at UC Berkeley took OpenBTS and they rewrote it so to use a spectrum sharing model, and so it's one of the great use cases for OpenBTS that we like to talk about. I think the point, we all talk about open innovation from the sort of sense of the thrill you get as good engineers, but let me make another point about open platforms invite new capital. There's not a lot of money, not a lot of venture money going into mobile infrastructure right now because the number of people that buy it typically are like 4. T-Mobile, Sprint, Verizon, and AT&T. And until we get some innovation out there, we're not going to see a massive amount of capital coming into the marketplace to stimulate, gigabit Ethernet or the mobile equivalent of a new access protocol. And so open platforms are that's the downside of that closed mobile architecture that we currently have out there. We like OpenBTS because it's software based, and it runs on everything from that small ARM BeagleBoard all the way up to a multi-core Xeon, depending on the problem you want to solve. The company started, as I mentioned, by building inexpensive infrastructure for Africa, Indonesia, Antarctica, and places like that. And more recently, we've expanded the software to move into the enterprise marketplace. And this was one of the reasons that we started working with 2600 hertz. In the enterprise market, to be clear, there's 2 specific and very, very different technical use cases. One is where AT&T magically shows up and they put a little cell inside of this building and suddenly we all have better coverage. It's still their network, though. However, if you believe that spectrum will fragment and there will be various forms of unregulated or lightly regulated spectrum available, then we can build our own network here and then gateway it to AT&T or Verizon or whoever the upstream operator is. We've all grown up in a world that says these phones don't work unless they talk to AT&T. And I just want to stand here and point out to you, how easily it is to fall into that trap, to make that assumption that only God can provide a mobile network. And that's simply not the case. So we have mobile networks there. We have mobile networks in the Netherlands with customers where there's unregulated GSM spectrum available. There are, in fact, networks out there, and personally I believe that mobile enterprise networks, real networks, not just extension of the carrier network, will become as common as enterprise Wi-Fi networks are today. Enterprises build their own data networks because they see the value of that. And enterprises, I believe, will build their own mobile networks to see the value of that as well. So recently in Las Vegas and also here, we did a demo of a couple different capabilities. There's a lot of legacy PBXs out there, and people have them for various reasons. Typically, less and less for phones and more maybe for conference phones. But they're there, and you have to integrate these into those mobile systems. If you build your own mobile network, and then it's very, very easy to integrate, because one of the key parts about OpenBTS I didn't mention is that in our software, we represent the mobile device as a SIP endpoint in the software. So all the voice, everything is converted immediately into SIP, which means we integrate very, very easily into the world of VoIP and the world of 2600 hertz. So we did a demo with one VM of legacy PBXs, and then with another VM we did a demo with 2600 hertz, and that's what we have going in the back of the room. Let me just put another pitch in for enterprise to kind of, I don't know, forgive me, but sort of kick you, because growing up thinking that only AT&T should run these is a mistake. If you run your own network, then you can do things such as have multiple identities. When this wanders into the building, it can become a business phone. It can have a business number automatically with no OTT app or anything like that. When it leaves this, it will go back to AT&T, and AT&T, you know, render unto Caesar and unto God, you know, and all that. So they can, you know, have their cake and we can eat it too. Privacy. We talked earlier, somebody was mentioning our friends in the NSA. Today, we all use these at work, but of course, the metadata is going up to God and back before it comes back down. And that's not exactly what enterprises would prefer, even if they're not against the NSA. So having a network in the building, your Wi-Fi stays in the building, but your voice currently does not. And there's no reason that it shouldn't. And again, that's the reason to have PBXs, among other things. Location-based services. I think we all have these, we all carry them, and we don't leave them lying around very often. And so the whole opportunity to develop applications based on where I am is there on the table to be had. None of this is available if AT&T's processing the call. Messaging and presence. We have people, friends who have integrated WebRTC into OpenBTS already. And so it becomes part, just from your point of view, just an IP communications platform. So I'm going to finish there, and then there's a bit of time left if you have any questions. Otherwise, I would encourage you to go to the back of the room where people far more skillful than I can answer most of your questions. Yes? The question was, what's the largest rollout that we've done? We have there's a couple of different answers. Because OpenBTS is open source, and we don't track how it's applied or where it's applied. The real answer is, I don't know. OpenBTS supports a number of software-defined radios. Range makes one. We've actually stopped making it. We're emphasizing third-party SDRs now. And so because of it's just being software, we don't really know. We do have some Tier 3 service providers in those rural, remote areas, and the largest network is something like 10 or 12 base stations currently for those. But that's real, I don't know, you and I would probably call it service provider quality. It has a different quality expectation than universities or something like that. Down in Antarctica, they're running, I think, an 8-node network with 1,200 instruments talking SMS amongst each other, things like that. Yes? The question was, if Spectrum becomes unlicensed, will they have the same problem that the wireless ISPs have? So my answer to that is threefold. First, there is, I'm venture that most of you don't know that in Europe, there are 3 countries that have a piece of GSM spectrum that is unlicensed today. Your iPhones will work in unlicensed networks in the Netherlands, in the UK, and in Sweden. It's legal to build a low power network, 200 milliwatts or under. But low power will cover quite a large space. So you can do that today. There are various ways to do, for instance, we look at a channel. When we bring up a channel, even though it's we assume licensed spectrum, we sniff the channel first to see whether it's busy or not. We look at the SNR, and some of the handover schemes and things like that we use they actually look at the channel characteristics to see if it's busy or not. And as we start to move more into lightly licensed or unlicensed use, we're going to raise the intelligence in how we do channel selection. You can always move around noise. We've learned that from some of our customers. For instance, we have a customer in Canada, and it's actually a French island off the coast of Canada, but it's close enough to Canada that what is legal spectrum there is unlicensed spectrum in Canada, and so there was channel noise and collisions and stuff like that. So that taught us that we needed to, be pragmatic and sniff the channel. So I think that you'll see adaptive behavior, and that's the point I wanted to get to. Because you have an easily tunable radio and you're completely software-based, there's no reason that you shouldn't be intelligent about your channel selection and be adaptive to how you handle noise and collisions and things like that. And then the last answer is it's only lightly intelligent today, but quickly I believe it'll become very intelligent because of the desire, my desire, everybody's desire to use lightly licensed or unlicensed spectrum. Yes?
Hey, microphone. Seeing something like Band 42 would be awesome. I think that your idea of converging the mobile into the enterprise integration space is amazing. It would be awesome if us as integrators could go and put an open BTS device or an SDR in an office environment or in a tower, in a building, and have people roam onto these networks. Obviously, the challenge is not, would this be a good idea or not? It's, we're not allowed. So if we don't see Band 42 succeed, what sort of things do you think we could do to encourage this to be a possibility? And that includes countries like Canada as well.
Mm-hmm. So, great question. It's nice to talk about what we'd like to see, but do we think it'll actually happen? I think it'll happen for the following reasons. One, large MNOs tried to do what 2600 is doing already. They tried to have, to bridge this with the PBX, and that bridge was in New Jersey, okay? And they tried that, and it failed. They say it failed. They don't want to go there again, and they want intermediaries, to do that job for them using newer, better technology. So that the MNO's not fighting you for that anymore, because they want new companies to come up and do that. That's part one. Part two is the fact that Google is out there. They have more money than God, and they're big and bad, and they're in Washington now and so forth, and they're actively driving this new auction model. If that happens, in that auction model, the big four operators potentially don't play at all. You could build a network, you talk to Google, you're done. And so that if I was a big four operator, I would be scared. And so my response would be, that hasn't happened yet, so why not go to the integrator community, the MVNO community, and say, okay, I'll partner with you to go to the enterprise. What I, the operator, wants is the SIM cards, so that when this thing leaves the building, it's part of my network. All right? That's what I want. That's all they want. They just want the SIM cards. And then when it's in the building, in return for getting the SIM cards, I'll allow my MVNO partner to enable the enterprise to use a low power, just a piece of spectrum. They all have this much spectrum. Even in San Francisco, AT&T is not using every last piece of its spectrum. So just allow the enterprise to use a low power piece, not interfering with the macro cells out there, and then there's get that relationship with the enterprise now before Google potentially comes into the market and disrupts the big market. The question was, do I think the carriers would allow that? I think that this is a discussion that is just beginning now, and I believe, come on, we all know how this goes. You find of the big four, you find the fast mover, the early adopter. We know the two, they're the smaller two, and if they go, then the larger two will follow. The MNOs, they have a ton of money, but they're not in a strong position these days. They're feeling under pressure from change, the change that you're talking about in this room, the change that we're all bringing in different ways. So, and they're scared of Google, obviously. They're not scared of me or of you, but they're scared of Google. So, yeah. Yes?
What is the business model of Range Networks? How do you make money?
The question was, what's the business model? So as a software company, we open source a full vertical stack of functionality But some of the operator-specific features, the stuff that's only relevant to a very large operator, we hold back. And think of it as a freemium model. So you can build, mobile networks. You can build 5, 6, 10 node mobile networks. You can build 20 node mobile networks, handover, authentication, all of that. But some of the functionality that's specific to a very high performance operator, we hold back, and then we sell that essentially an OEM relationship with people who want to build the specialized hardware. If an outdoor base station is not something you buy at Fry's Electronics. There's people that build those, and we sell our software to those people. In the enterprise, it's the same thing. Even though you have a great demo in the back of the room there, if you believe what I say will happen, there will be specialized little pucks on ceilings that'll look a lot like switched Wi-Fi, and they'll be mobile capable pucks. And so the market, we believe